Hello everyone, Rahul here. So today we are going to talk about the plate tectonics. Last time we discussed the internal structure of Earth. So what we discussed is that Earth consists of crust, mantle and core. These are divided on the basis of chemical composition. Now moving forward. Now other one is the mechanical classification wherein the Earth crust and upper mantle is divided into first of all continental oceanic crust, then lithosphere which includes the continental and oceanic crust, and then asthenosphere. And asthenosphere is plastic layer. See here it is mechanical layering. Remember the crust mantle core thing is chemical layering. So in this lithosphere what we have it till 100 kilometers and it is relatively cool, brittle and strong. Okay. In the asthenosphere we have hot, lower viscosity and weak liquid. Actually asthenes means weak. So we have a plastic flow here. And then there is mesosphere. Mesosphere is some part of upper mantle and complete lower mantle. Now this is called mesosphere. And below mesosphere the core is called barysphere. You should remember it. It can come in handy in the pre-exams. Barysphere. Okay. So for this chapter we need to remember till asthenosphere. Let asthenosphere approximately extend to 200 to 300 kilometers and lithosphere extend till 100 kilometers. Now everybody knows that the continental crust is 20 to 70 kilometers thick and is composed of lighter granite, and its density is approximately 2.7 grams per cubic centimeter. Now I want to tell you one more point is that it is thinnest in areas like the Rift Valley of East Africa and in an area known as Basin and Range provinces in the western United States, and the continental crust is thickest beneath the mountain ranges and extend into the mantle even. Okay, so both of these crust types, like that is oceanic as well as continental, are composed of numerous tectonic plates that float on the top of mantle, that is on the top of asthenosphere, whereby mean is that the lithospheric plates, or I will just tell you what do you mean by plates, they can move bodily over the plastic asthenosphere. So let's move ahead. Now what are the lithospheric plates? Now Earth's crust consists of several large and several small rigid and irregularly shaped plates which carry continents and the ocean floor. Obviously lithosphere is broken up into many different plates, and below that we have asthenosphere which is plastic flow. So the major plates are divided into major and minor plates. The major plates are 7 major plates and rest are minor plates. Now these plates move around very slowly in the order of few millimeters each year, and this led to the building up of stresses in the plates and continental rocks above, which is released by volcanism and earthquakes. Now the movement of the plates occurs why? It occurs due to the movement of molten magma inside the earth. You should remember that. Why the movement of plates occur? It is due to the movement of molten magma inside the earth. So the molten magma inside the earth rotates in a circular manner. So this leads to movement of the lithospheric plates also. I will just explain to you this phenomena by the help of an activity in the next slide. Before that I should discuss the term tecton. Now tecton means builder, literally. So these tectonic activities are the building activities on the part of our mother earth, because it leads to formation of mountains and volcanism, etc., etc. So internal energy of the earth is released. So the tectonic activities mainly include folding, faulting and general deformation of the earth's surface. So the activity I was telling you is that how the movement in the asthenosphere leads to movement of the lithospheric plates. First of all, see. Now when we heat, suppose this is core, where there is in the outer core there is radionuclide disintegration, which leads to production of energy. This energy heats up the upper mantle also, and this mantle is being plastic and weak can flow. So it flows in a circular manner. I have already told you that due to this flow we generate waves, like we generate waves on the ocean because of the flow water inside. Here also we generate waves, and these waves lead to the movement of this cork also. This cork moves along with the movement of the plates. Assume this cork as lithosphere and this water bulk as asthenosphere. So the movement in the asthenosphere leads to the movement of the solid cork above. So this is the concept of the plate tectonics, that why do plates move. So let's move ahead. Now there is one more very important concept called mantle convection. That is how our oceanic crust is consumed. Now first of all, one thing you need to remember is that continental crust is way older than, greater than oceanic crust. Oceanic crust is of the order of 200 to 300 million years ago, or million years old, but continental crust is of order of 2 to 3 billion years old. Okay, so why it is, we will just discuss it now. Now in the Atlantic Ocean we find MOC, mid oceanic ridges. These are the like high cliffs that we see along huge area along the between the Americas and Europe and Africa. So how do they form? First of all, I have already told you that in mantle we have this circular convectional currents of magma moving on. So these convectional currents, what they do is, first of all they flow upwards. This is called ridge push. This leads to magma flowing upward and hence releases the energy. And when this splitting up of the oceanic crust occurs here, so the magma is released, and when it solidifies, it leads to formation of this ridge, which we call mid oceanic ridges. Now this process happens again and again, and hence this ridge moves sideways because this oceanic crust splits up again and new oceanic crust arises and the older one moves here. Okay, again the explosion or the splitting of earth happens, then magma comes out, again the older one moves here and the newer ones comes here and the second one moves here. Fine. So this process happens again and again, and hence the slab gets pushed towards the continental crust. So when this crust collides due to this opening of the oceanic crust and further movement, when it collides with the plate here, then the oceanic crust or the plate subducts or moves under the continental plate. So when this moves under the continental plate, because of increase in temperature, this melts and forms trenches here. Trenches means deep valleys inside the ocean. Largest one is the Mariana Trench. And again, after the melting, it again flow back in the same cycle. So this is called slab pull, this is called ridge push. The magma flows out, then cycles again, and then here it forms trench, and then again due to conversion into liquid it flows back into the cycle, same cycle, convectional currents. Okay, so let's move forward. Now these are the lithospheric plates I was talking about. There are 7 major plates. I will name them one by one. First of all, Australian plate, Antarctic plate, Pacific plate, North American plate, South American plate, African plate. Fine. How many are done? 1, 2, 3, and Eurasian plate. So these are the 7 plates. Fine. 1, 2, 3, 4, 5, 6, 7. Fine. Rest all Philippines plate, Juan de Fuca plate, Caribbean plate, Indian plate, Arabian plate, then this Nazca plate. All these are minor plates. Fine. So I have already told you that the lithosphere floats over asthenosphere, that is plates float over asthenosphere. So this is the basic map of the plates. Please remember this. Now let's move ahead. Types of plates. Now there are 3 types of plates. First of all, first one is oceanic. That is, it is completely under the ocean. Other one is continental. That is, most of it encompasses continent. And third one is partially continental and partially oceanic. That is, some part of it is in continent and some part of it is in ocean. Fine. So let's move ahead. Now, what are the types of plate movements? There are 3 types of plate movements. First one is convergent boundary interactions. Second one is divergent boundary interactions. And third one is transform boundary interactions. Now, some plates come towards each other and collide with each other like this. So when they collide, they crumble like this, or they get compressed. So when they collide and crumble and get compressed, so they will crush against each other, you can say. One thing will happen, it will become like this, from like this. Fine. The other thing can happen is one will move under the another. So this is called subduction in geography or geology. Subduction. First one is collision or crumbling. Other one is moving below the other plate. It is called subduction. Now the second interaction is when the plates move away from each other. It is called divergent boundary. That is away from each other. These we see in mid-oceanic ridges that I just told you in the Atlantic Ocean. The third one is when the plates move horizontally past each other like this. Fine. This is called, one is moving like this and one is moving like this. So these both have friction between them. Like we rub our hands, but our hands are not colliding. They are rubbing horizontally. So this is called transform boundary. This kind of boundary we find in North Anatolia fault. Anatolia fault in Turkey, and also San Andreas fault in California. Fine. So the movement of these plates have changed the positions and size of continents over millions of years. Obviously, you know about the continental drift hypothesis, and I will also be dealing with it in the future classes or lectures. So obviously this will lead to the change in the position and size of the continents, and hence they have influenced the landforms that we see on our Earth. Right? So now coming in detail a little. First of all, about the convergence of plates, that is convergent boundary interactions. Now it is very important. I need to divide it into 3 parts. First of all, when 2 oceanic plates collide, that is oceanic interactions. Second one is oceanic continental. Third one is continental. Okay. So these 3 differ somewhat with each other. Now what happens in oceanic and oceanic interaction? In this type of collision, one of the plates is subducted under the other, creating a deep oceanic trench. Now see, here is water. Here are the plates, suppose. That is, one plates move under the other. Fine. one oceanic plate 1, oceanic plate 2. One moves under the other, fine. So this is called subduction, and hence they create a deep oceanic trench. For example, Mariana Trench. Now the Mariana Trench in the Pacific Ocean is created by the collision of the fast moving Pacific plate against the slow moving Philippines plate. I will show you in the diagram. See here. Are you able to see? This is Philippines plate. This is Pacific plate. This is moving fast, and this Philippines plate is moving slowly, and this is moving this side, this is moving this side, and the Pacific plate moves under the Philippines plate. That is, Pacific plate subducts under the Philippines plate. Now this convergence of these oceanic plates also creates chains of volcanic islands called volcanic arcs that we call ring of fire. Now this is very important. You remember last year in UPSC mains, this question was asked, that how the Pacific Ocean islands have been formed. It is because of this reason. Now when they subduct, they form arcs of islands. Now how they are forming arcs of islands? Arcs are created by the friction of subduction, which creates hot plumes of magma at the interface of two plates. That is, at the boundary of two plates, hot plumes of magma comes out. So this hot plume of magma rises to the surface of Earth and hence forms volcanoes. And so this is the main concept, that how these island arcs are formed. Now another phenomena associated with the collision and subduction of the plates is earthquakes. So this gliding of one plate under the other is not smooth but produce jerks, and hence produce seismic waves, which we experience in the form of earthquakes. This may be cause of tsunami because it is oceanic interactions, and that's why in the Pacific Ocean we get so many tsunamis. Japan is facing tsunami once in 5-6 years, you can say. Fine. So first one is oceanic interactions. Now second one is oceanic continental interactions. Now what happens is that the oceanic plate subducts under the lighter continental plate. So once again we get the formation of trenches, volcanoes and earthquakes. This collision causes sediment deposited on the ocean floor to be piled up at the continental plate boundary, and also there is creation of hot magma plumes, which also causes the continental crust to deform and hence produces mountains. Now I will explain you with the help of example. See Nazca plate. Nazca plate is oceanic plate. Now this subducts under the South American plate, which is continental plate. Due to this subduction, this oceanic plate or the sediments deposited on the oceanic plates will get consumed. Fine. Also, when this subducts under the plate, there will be formation of mountains that we see in the form of Andes here, right? So remember this with the example of Andes. Now this is the second one. Now coming to the third, in which the continental plates collide. Two continental plates collide. Once again, one of the crustal plates is subducted under the other, which produces earthquakes. A mountain range is produced at the plate boundaries because there is deformation of rocks, and some of the rocks in the mountain range may be sedimentary and may have been set down in the ocean environment that existed between the two continental crust prior to collision. Now if I am not taught you about that continental drift hypothesis, but still I will explain you little bit here. Now there was supercontinent named Pangaea before, and Indian plate was also part of that one single large landmass. Now Indian plate started moving towards the Eurasian plate. and before the Indian plate started moving towards the Eurasian plate, there was Tethys Sea between them. This Tethys Sea was actually oceanic crust, and above which water was there. So when this Indian plate started moving towards the Eurasian plate, this oceanic crust got consumed, that is sediments started moving forward of the Indian plate. So when the Indian plate subducted under the Eurasian plate, we had the formation of Himalayas, right? Very important. We had the formation of Himalayas. So you can now remember all these three types. I have given you the examples of each and every type, right? So in summary, the modern plate tectonic theory says that the surface crust of the earth is composed of many independent segments called plates. These plates have the ability to move horizontally by gliding over the plastic asthenosphere. So in some cases, the plates can collide with each other at the plate boundaries, causing subduction and the production of earthquakes, volcanoes, mountain building movements, and oceanic trenches. At other plate boundaries, the plate may move away from each other because of sea floor spreading. I will tell you what is sea floor spreading. See here. This is sea floor spreading because the sea floor is moving to left and right of this MOC, mid-oceanic ridge. This is called sea floor spreading, right? So this is due to divergent boundary interaction. And the third one is when the plates horizontally move past one another, which creates transform faults and earthquakes. So thank you everyone. I hope you like this lecture. Please like, comment and subscribe to www.decipherise.com. Please like our Facebook page. Thank you.